Hi, so today we're going to talk about Ohm's law, which is named after a German physicist called George Ohm. First, we'll talk about electric circuits. An electric circuit is composed of individual electronic components, which are connected by conductive wires through which electric current can flow. In a circuit, electrons, which as you might remember from previous science classes, have a negative charge. These flow from the negative terminal of the battery to the positive terminal of the battery. There are three important metrics for the performance of a circuit, and these are often analyzed when we talk about a circuit. First, there's electric current, which is the rate of flow of electric charge past a point or region. It can also be defined as charge per unit time, which measures how much charge is flowing past a point in a circuit in a unit of time. For example, with respect to this circuit, we might be interested in exploring how much charge is flowing past point A in perhaps a second. This is measured in amperes or amps, and current flows from a high voltage to a low voltage. You might remember that this is the opposite of what was previously mentioned as a flow of electrons, which flow from the negative to the positive terminal. Current, on the other hand, flows from the positive to the negative terminal. So these are opposing directions. The next metric is voltage, which is the name for the electric force that causes electrons to flow. It's the measure of potential difference between 2 points in a circuit. Voltage may come from a battery or, for example, something larger like a power plant. It can also be defined as potential energy per unit charge. It is measured in volts, which is often shortened to V in circuit schematic diagrams, and volts are named after Italian scientist Alessandro Volta. Finally, resistance is a measure of how well a material or object conducts electricity. Low resistance means the object conducts electricity well, whereas the high resistance means the object does not conduct electricity well. In other words, it is the tendency to impede electric current, and it is measured in ohms. Here, we've displayed a basic circuit with a battery, in this case made up of 3 cells, and a bulb, a resistor, and a switch, which is like the light switch you find on switchboards in your homes. It turns a circuit on or off, and in this case, it turns the bulb on or off. Here are some common circuit components, such as a cell, a battery, which of course provides voltage, a resistor, which provides resistance, and devices like a voltmeter and ammeter to measure voltage and current. There is also another device called a multimeter, which can measure all three: a current, voltage, and resistance. So what exactly is Ohm's law? Like we said before, Ohm's law is named after German physicist George Ohm. Ohm's law is a mathematical formula which relates electric current, voltage, and resistance, which we said were the 3 major components that make up a circuit and metrics that we use to analyze a circuit. As a refresher, electric current is the rate of flow of electric charge past a point or region. Ohm's law states that voltage is equal to current multiplied by resistance, which is often shortened to V is equal to IR, where V stands for voltage, I stands for current, and R stands for resistance. Ohm's law describes the way that electric current flows through a resistance when different electric potential, that is voltage, is applied at each end of the resistance. So now we will consider the analogy of 2 water tanks as displayed here. As we can see, the water tanks look similar, except that the water tank on the left has a wider pipe attached to it compared to the water tank on the right, which has a narrower pipe. Here we can say that the water in the tank itself represents charge. The pressure in the tank represents voltage. The flow of water represents electric current, and the width of the pipe, which we can see is varied between the two pipes, represents resistance. We can understand that more water will flow through the pipe, that is current, the more pressure is applied, that is voltage, and the bigger the pipe, that is lower resistance. We can also specify that the pressure at the end of the pipe can represent voltage. The more the water in the tank, that is the higher the charge, the more the pressure at the end of the pipe, that is at the bottom where the water flows out. We can think of this tank as a battery, a place where we store a certain amount of energy and then release it. Let's say that we define the pressure of the water to be 1 volt and the narrowness, that is resistance to flow, of the pipe to be defined as 1 ohm. Using Ohm's law, remember that voltage is equal to current multiplied by resistance. Pause this video now and try to find the value of current using the values of voltage and resistance. In order to solve for the value of current, we can say that 1 volt is equal to X amps multiplied by 1 ohm. If we solve for amps, we can see that 1 volt is divided by 1 ohm, which gives us 1 amp. Confirm if this is the answer that you got. If you are confused about how this answer was arrived at, leave a comment down below. Using this similar analogy, let's now look at the tank on the right with a narrower hose. Because the hose is narrower, its resistance to flow is higher. Let's define this resistance to flow as 2 ohms for the purposes of us solving. The amount of water in the tank is the same as the other tank, and let's consider that the pressure is the same too. That means that voltage remains at 1 volt. Our equation for the tank with the narrower pipe will be the same as the equation that we solved for previously with a different resistance value. So we can say that 1 volt is equal to X amps multiplied by 2 ohms, since the resistance has increased from 1 ohm to 2 ohms due to the pipe becoming narrower. Pause now and solve for this yourself. To solve for the number of amps, we would divide 1 volt by 2 ohms, which gives us 0.5 or half an amp. Confirm if this is the value you got when you solved it yourself. If you're still confused about how this answer was arrived at, please leave a comment down below. So this marks the end of our video and our tutorial on Ohm's law. Ohm's law is especially important for our activity because we want to calculate how much energy is needed to light up our LED light. In this case, our energy source is the sun, which is acting like a battery to provide energy. In terms of a circuit, this is similar to a battery, or in terms of the analogy of the tank, it's similar to the actual water in the tank and the pressure that is applied to make the water flow. In our case, we will use wires to transfer the solar energy gathered by the solar panel in the circuit to the LED light. Thank you so much for tuning in, and I hope this tutorial on Ohm's law was very informative. Please leave a comment down below for any feedback or any questions.